Gravity slows down time. Now, what does that mean? So, to understand this, let us consider that this area in which I am has greater gravity than the area in front of me, and the gravity of this area does not affect that area. Let us just consider that. Now, uh, now, if I move my hand like this at this speed in this area in which I am, people outside will see my hand move like this. Now, for me, if I look at my watch, again, I'm in the place with gravity, with greater gravity, and just as I said, gravity slows down time. So, if in this area of gravity, if I was to look at my watch wouldn't run at a slower rate, even though gravity slows down time. My watch actually would, to me, will be going at the same speed as it normally does. In fact, I will be breathing at the same rate as I normally do. My watch will be going at the same rate as it normally does. My heart will be beating at the same rate as it normally does, even though gravity slows down time. So what does it mean when we say that gravity slows down time? So for everyone in that gravitational field, everything would be moving at the same rate as it normally does, considering that those objects are also in that gravitational field. Everything outside that gravitational field would again not be moving slow, not even be moving at the exact same speed, but be moving at a faster rate. Now, I just said that gravity slows down time, so why does everything outside starts moving at a faster rate? So, when I say that gravity slows down time, for me everything, because I am in the gravitational field myself, and my watch is also in the same gravitational field as me. If I look at my watch, it will be going at the same rate as it normally does for me. Now, let's get out of this gravitational field. And so let's say now I'm out of the gravitational field. I'm in a place with, let's consider there is no gravity here. And I just take my hand, which has the watch, and put it in the field of gravity. Now, normally, if that would actually happen, my arm will start aging at a slower rate than I'm aging out here. So that would cause problems. But let's say that nothing happens. I don't get harmed if I do that. However, if I look at my watch shall be going at a slower rate, because my watch is in the gravitational field, but I am not. Everything in the gravitational field will age or move slowly than it does outside that field. For example, if I was to, let's consider that there is a very strong gravitational field in front of me, and let us just consider that that field does not affect us. Its effect is only in that area in front. Now let's send a person into that gravitational field. Now, if I was to look at that person and he was to move, he would be moving at normal speed. But if I was to look at him from outside that gravitational field, he would be moving slowly. He would be breathing slowly, and he would be aging slowly. So let's consider that one day he passes there is equivalent to 1 week here. So how is that possible? Because the person there is aging slowly. His watch is moving slowly. 1 week passes here, and his watch is so slow that it shows that only 1 day has passed, and he felt like only 1 day has passed, and he has aged as if 1 day has passed. When he comes out of that gravitational field, we can ask him, how much time did you spend in there? He would say 1 day. But we would say, no, you've spent 1 week, according to us.